Hi, welcome. In this video, we're going to go over friend functions and overloading operators. So let's get started. All right, so let's just review a little bit about classes. So classes provide encapsulation, abstraction, inheritance, and polymorphism. Today we're going to talk a little bit about encapsulation and abstraction. C++ is an object-oriented programming language that you create classes and you create objects of your classes. All right, so an object is a variable that has member functions and the ability to hold data values. So when you create a class and you declare objects of your class, those are the variables of your class. So the object is actually the value of the variable. So if you have class vegetable and I say, vegetable is my class, V1, V1 is an object of type vegetable. V1, V2, those are objects of type vegetable. Those are variables that hold the value of a vegetable. Usually you want to make, you have private members and you usually want to make your variables inside of your class, not your object variables, your variables in your class, private, and then you have public, which would be your functions that are accessible outside of your class. Functions that include things like your accessor and mutator functions and anything that you, any member functions that you access outside of the class using the dot operator. There's also protected, which we won't be talking about today. Okay, so you want to define all of your variables to be private, and if you do define your variables to be private, then you would define accessor or getter functions and mutator or setter functions in order to access the private member variables, because private member variables can only be accessed through your class member functions. But today we're going to talk about another way to access private member variables, and that is through friend functions. So encapsulation is a way to hide data. It's a technique to make all the variables in your class private and control access through only public, possibly protected, but mostly public functions. This allows you to modify all of your variables, and it doesn't, and your data structures. It allows you control over the objects that are in your class by making the data private. So the idea is to make all of your member variables private and then use accessor and mutator functions to access the data. But sometimes you want to use friend functions, and today I'm going to give you some motivation and some examples on when you would use friend functions. But first, let's just review things about using accessor and mutator functions and declaring objects and how a class declaration is set up. So this over here, this would be the class declaration. The name of the class is day of year. All of these are, this is the declaration. You will see these are just prototypes. So this would be, we're going to be doing separate compilation. This would be in your .h file. And our member variables are private. For each private member variable, you want to include a accessor or mutator function. Here, this would be in a function. So the implementation would use the scope resolution operator, which I have examples later, but these are your default constructor, your explicit value constructor, your accessor and mutator functions are here, and then this is a member function, and this is another member function. So those would all use the scope resolution operator for the implementation. When you use the scope resolution operator for the implementation, that would be in a .cpp file. That's where you would put the implementation. And for our purposes in this class, this part right here, this would also be in a .cpp file, but this would be in your main.cpp file. So in your main driver, where you test objects of your class, the .cpp for implementation would have the scope resolution operator. The .h is the declaration, and then when you want to test and create objects of your class, we're only going to be using 3 files, but you could use a lot more, but we're just going to have our driver, where we're going to declare objects of our class and have our non-member functions, our .cpp where we do the implementation, and the .h file where we do the declaration. So our next assignment, you will be having a separate compilation. All right, so this right here, we are declaring one object of type day of year and a second object of type day of year. Both of these objects are calling the default constructor. So the default constructor would be implemented in our .cpp file. And then we want to enter today's date. That would be using the input function, which is a member function that would be in the .cpp file. And then this is the set function, which is right here. And then we would have to use the accessor functions in order to get values and compare to see if they are the same, if they're in the same month. Okay, a member function is a function that is associated with an object. You list them in the declaration as prototypes, just like I showed you, and for implementation, you would use the scope resolution operator. We've already done this, so this should be review for you. So here's an example. This would of a member function. So this would be in your .c. So you would have a day of year .h file, and that would have your declaration in it. And in your day of year .cpp file, you would have the implementation of all of your functions. So your day of year CPP file would have your constructors and your 4 other functions. And your member functions have access to your private member variables directly without using a dot operator or anything. Obviously, they can access your private member variables because they are member functions that are part of your class. This is the scope resolution operator. This is the name of the class. This is the return type of the function. This is the name of the function. Okay, so here's another example of a member function. So this is class of vegetable, and this class has another member function, calculate profit. So this function is has the scope resolution operator. So this would be vegetable.h. We're going to have a file called vegetable.h, and you will have a file called vegetable.cpp. And in your vegetable.cpp, you will have the implementation of all of your member functions. And in the .h file, you will just have the declaration where your member variables are private and your functions are public. And we're also going to be introducing friend functions and overloading operators shortly. So what is a friend function? A friend function is not a member function, but it does have access to the private member variables by using the dot operator. So it doesn't have direct access. It has to use the dot operator to access the private member variables. You put the friend function in your declaration, which is your .h. You put the prototype of the friend function in your declaration so it can so it's declared and it can have access to the private member variables. And I'll tell you why in a moment. Okay. It does not use the scope resolution operator. You do not list the class name. The implementation is not a member function. It just gets declared in the declaration so it can access. It doesn't need to use accessor and mutator functions to access the private member variables. So here's an example of a non-member function. So this function is a non-member function. This is not a friend function. We're going to go through leading up to how to do friend functions. So this function takes 2 pass by value objects. So you're going to pass it by value, which means this function is going to make copies when it's called. It's going to have one day of year object and another day of year object, and it's going to compare if those days are equal. It needs to use the accessor functions in order to get the month and compare them, and accessor functions to get the day and compare them. So this is a non-member function. It's not a friend function. It's just a function that uses accessor, that has to use the accessor and mutator functions in order to access data in the class. Now, instead of passing by value here, you could pass by constant reference, which I'll show you that as well. Constant reference means that you must have values. So the nice thing about using constant reference parameters is that it ensures that you do have values. So they're like value parameters, but you're not making extra copies. So both will work, but sometimes you don't want to make extra copies because your objects might be very large. So here is doing the same thing, but we're using a friend function. So you notice that your friend function is listed here in the class declaration. It has a keyword friend, the return type, the function name, and it takes two objects of type day of year. When you do the implementation here, you do not put the keyword friend on the implementation. Then you just implement it just like any other programmer non-member function. The return type, the name of the function. It has two value parameters, but you will notice here that it doesn't need to use accessor. It can access the month using just the dot operator and access the day using just the dot operator. So you want to use friend functions or non-member functions if you're going to be manipulating or comparing or doing any kind of data with more than one object, because here your member functions, you would use member functions if you're only working with one object of type day of year. But here you're working with two objects. So how are you going to write a member function that compares two objects? You need to use a non-member function, and then to make it easier and able to access the private member variables with just the dot operator and not have to use the accessor and mutator functions, you use a friend function. So this, just to remind you, this is a not friend function, just a regular non-member function that needs to use the accessor functions in order to get to the data. And here is the same thing, only because we listed this in our class declaration as a friend function, we can access the private member variables right here by using just the dot operator. And you would use non-member functions when you are dealing with more than one object. So we're comparing two different objects of type day of year. So you want to use a non-member function, and you want to use a friend function because the friend function can then access the private member variables with just the dot operator. All right, so now we're going to do the exact same thing, only this time we're going to overload the equals operator, or the equality operator. So this is very nice because instead of having to call the function, so if we used it the way we did equal, you would have to call the equal function, and then you would have to pass it today, and I'll just say Bach here. And then you would be like if equal. So this would be the function call on the previous slide to the function called equal, and you pass it the two parameters. By overloading the operator, you just have the keyword friend here in our declaration, the keyword operator, which operator you're overloading. Also said that you could use pass by value parameters, or you could use constant reference parameters. So I'm just showing you another example using constant reference parameters instead of value parameters. That way you're not making copies. Then you can access, because this is a friend function, you can access the private member variables directly without using the accessor functions. And then to compare, instead of making a function call and passing it parameters, you can just do a direct comparison like this. If today equals Bach birthday. So that's overloading the operator. That's overloading the equality operator. This is not an assignment operator. This is a comparison, like equals, less than or equal to, greater than or equal to, less than, greater than, plus, minus, multiplication. So you can overload a whole bunch of different operators depending on what your motivation and what you want to do. If you are dealing with most of these operators would deal with more than one object of your class. So therefore it would be done using a non-member function. And if you want to access your private member variables with just the dot operator, you use a friend function. All right, so here is an example. You could have an add function. And with that add function, you have to pass two numbers to it, or you could overload the plus operator and then you just add the two together. And this is the same thing that I just showed you with the equal. You would have to pass the two dates, but here you could just use the equality operator. Since an operator is really a function, operators can be overloaded. You just have to use the right syntax. Here's another example. This is with class vegetable. So there's two overloaded functions. The first one is plus. So what this does, so the precondition here, this is just closer up. The precondition is that vegetable 1 and vegetable 2 have values because they are constant reference parameters. And it's going to return the concatenated name of the two vegetables. So it's going to go to VG vegetable1.name plus, it's going to return vegetable1.name plus vegetable2.name. If this was the implementation, you would not have the keyword friend here, and you would have obviously opening and curly braces, and then you would do return vegetable1.name plus vegetable2.name. So that's much nicer than having to use vegetable1.getName. So this is just a way, you can do it that way too, but this is just a way that you can access the private member variables directly with the dot operator. This is this other function is going to compare, and it's going to return true if the cost per pound of this vegetable is less than the cost per pound of this vegetable. So let's take a look at the next slide. So here is here's how you would how the implementation would look. These are non-member functions. You don't have the word friend here at the beginning. You don't have the scope resolution operator. You just you're doing two different objects. So because you're doing two different objects, you want to use a non-member function. A friend function can just access directly with the private member variables using the dot operator. So, and then you can compare very nicely if V1 is less than V2, anywhere that you are going to utilize, you're going to do this kind of comparison. And here, this is the, those are the operators that are being overloaded. This is going to add the names together. You add two names together. And these, so this right here, this part right here, this would be in your main function, or, this is just showing how you would utilize these function calls. This is not complete code, obviously. All right, so you should have accessor functions, and you should always include them because to be complete, you should make your private member variable, your member variables private, add accessor and mutator functions for each private member variable. Use a member function if your task involves only one object. Use non-member function if it involves more than one object, and that would be a good place to try using friend functions. Okay, then we just, this is just a little bit about what an abstract data type is. So when you create your classes, you want to be able to just give the interface how to use your class, but the details on how everything is implemented and these concepts, what we've been talking about, making your private member variables private and having control over how your class is implemented, and you don't need to that doesn't need to be shared, separating the declaration from the implementation. Those are all ways and techniques to create abstract data types. So an abstract data type, in your interface, you show your public member functions so that if someone wanted to use your class, like if we are using the string class, then you can know that there's a length function, there's a begin function, an end function. And so that the string class is an abstract data type in the sense that you can declare objects of type string, you can use the functions, but the details of how the string class has been implemented is not it doesn't matter as long as it works as expected. You put comments that explain how to use your different public member functions, and that's all you should need in order to use this any object. Why would you do that? Well, if you want to change your implementation, it doesn't require. So if things in the implementation need to be changed, but someone is already, like if the string class needs some updates, it shouldn't matter to those who are using the strings. So anyone using the objects of your class, if you need to make updates in the way that things are implemented, it shouldn't impact any programs that are already using those objects. It also makes it much easier to divide large programs into smaller tasks and dividing up the work. Thank you.